they will make more sense as we go over them. then which number am I replacing y with? -1. And I'm asking, is that less than or equal to -1? Well, 4 times 1 is 4. 5 times -1 is -5. So we're asking this. Now, what is 4 plus -5? -1. Is -1 less than or equal to -1? Yes. So that is a solution. Okay, I'm going to solve it again, except this time I'm replacing x with what number? And I'm replacing y with what number? Okay, what is 4 times -3? -12. What's 5 times 2? Is that less than or equal to -1? Well, what is -12 plus 10? Is -2 less than or equal to -1? Be careful on these. You just look at it on a number line. Here's 0. Here's -1. Here's -2. Is -2 less than or equal to -1? Yes.
It would be.
So the answer is yes, it would be. Okay, last one. I'm going to replace x with what? And then I'm going to replace y with what? 4 times -1 is -4. 5 times 1 is 5. And I'm asking. So now what's -4 plus 5? 1. Is 1 less than or equal to -1? Look at it on the number line. Here's 0. Here's 1. Here's -1. Is 1 less than -1? No. So this is no. So I have a no, a yes, a no. Everybody follow me on those. It's just like if it was an equation. Now, how do we graph an inequality? We graph it the same way as we would if it was an equal sign. So I'm going to actually change the inequality symbol to an equal sign. And I'm going to graph the equation, because now I've made it an equation when I change it to an equal sign. And then, here's the key. If the original problem had it was a less than or greater than sign, we used a dashed or a dotted line when we connect the points. If it's a greater than or less than, greater than or equal to or less than or equal to, we use a solid line just as if it was an equation to connect the dots. Now, the part that's new, the piece that's new, is we have to show on the graph which ordered pairs above or below the solution, and above or below the line is a solution. So we test a point, and then I'll have to show you how to do this. We test a point in one of the half planes to check whether it's a solution. If the test point is a solution, we shade that half plane. If it's not a solution, then we shade the other half plane. I'll show you what that looks like in just a second. Okay.
I have a question.
Yes.
Like how you underline the less than or greater than, is that changing versus?
Yeah, we're still going to change it to an equal sign. It's just going to determine how we graph it. Okay, so on this one, I'm going to change the inequality sign to an equal sign. So instead of writing y minus 6x is greater than or equal to 8, I'm going to change it to equals 8. Alright? So all I did is I replaced this with that. Now, is that in function form? Is this in function form?
No.
No, it's not. To get it in function form or slope-intercept form, that's what I want to do. I want to get it in slope-intercept form. To do that, I'm going to add 6x to each side. When I do that, I get, I'm going to bring it down here. I get y equals 6x plus 8. I added 6x to each side. Okay, so now, is that in slope-intercept form from yesterday? Yes. Can I identify the y-intercept, where that line crosses y. What is it? Where it is it?
Is 8.
8, 0, 8. Okay? So it has a y-intercept of 8, which represents 0, 8, which is here. 0, 8. Now what's the slope?
It is 6 over
6. So I would write it as 6 over 1. Okay? So that means I'm going to rise 6. 1, 2, 3, 4, 5, 6. I'm going to run 1. Okay? Now if I want to get a third point, I can reverse it and fall 6. 1, 2, 3, 4, 5, 6, and run 1 this way. Okay? And still, is that a positive line? Yeah, because the number in front of x is positive. Now, because I had this as an inequality symbol, that box tells me to connect the dots how? Solid or dashed line? Solid. So, I'm going to connect the dots using a solid line like this. Have I done anything different really so far from what we did yesterday? No. Have I done anything different? Now, I have to figure out, since this is an inequality, either everything on this side of the line is a solution, or everything on this side of the line is a solution. If it was just an equation, the only thing that would be a solution would be the ordered pairs exactly on the line. But it's an inequality. So either everything on this side makes a true statement, or everything on the other side makes a true statement. So how do we know? Well, we're going to pick a point on this graph. Guess what's the easiest point to pick? 0, 0. Okay, so which is right here. 0, 0. There that is. So is that on the right of the line or the left of the line? Well, it's to the right of the line, right? It's on this side of the line. Okay, because here's the line. So this points to the right. If it was over here, it'd be on the left. Okay, so it's on the right of the line. So what that means is I'm going to replace both x and y with 0. And I'm going to ask, is 0 greater than or equal to 6 times 0 plus 8? Is 0 greater than 0 plus 8? Is 0 greater than or equal to 8? No. Okay, so 0, 0 is not a solution. So since this doesn't work, and what side of the line was this on?
Right.
The right. No ordered pair that is to the right of this line works, which means that every ordered pair on this side works. So what I would do is I would take my highlighter, and I would shade everything on this side of the line. And that shows that if as long as I pick an ordered pair that's over here, it makes a true statement. So that's the difference from yesterday. So we're going to practice that right now. We're gonna do 2 different ones that's on the next page. Okay. All right. Look at number 5. Is that written in slope-intercept form? Yes. Okay. I'm just gonna go ahead and rewrite it like this: y equals x minus 9. Now from there, can I identify the So I would take my highlighter and I would highlight everything on this side of the graph. Would I include the line? No. I would only include the line if it was solid. Okay, last one. Is that in function form? Is it in a slope-intercept form? No. So I need to subtract 1/8x from each side. When I do that, I would get y is less than or equal to -1/8x plus 5. I just subtracted that from both sides. Now, I'm going to rewrite it as an equal sign, right? Can I identify the y-intercept? What is it? 0, what? 5, which is right here. What's the slope? -1/8. So I'm going to fall 1, run 1, 2, 3, 4, 5, 6, 7, 8. Fall 1, and I can't, those are the only 2 dots I can fit on that plane. Now look at the original inequality. Am I going to connect those dots with a solid line or a dashed line?
Solid.
Solid. Okay, so I'm going to go back and I'm going to connect it with a solid line. Okay. Now, the only thing left to do is test what point? 0, 0, which is right here. And is that below the line or above the line? Below the line. Okay. So I'm going to replace both x and y with 0. And I get, is 0 less than or equal to 0 plus 5? Is 0 less than or equal to 5? Yes, 0 is less than 5. So because this is true, I'm going to take my highlighter and